hope you understand last video about the A searching algorithm. In this video we continue have one more example about the A star searching planning. So in this example we create the map 14 column and 10 rows, and once it means for the obstacle and 0 is empty. So we ask the robot go from this position to this position, how they create the path to avoid the obstacle. Okay, and let's try run this example and so how they create the path. You see here, right here, they will the map right here, and they create a path right here to the goal. They expand the calculation, expand the neighbor, and to find the goal. They already have the 102 iteration to find the goal because they use the breadth first search, one of the graph searching methods to figure out the goal. Here's the map, and for example, if we try how to so different location, 2 0 2, okay, and let's see how they create a new path. Okay, they create a new path from this location to this location. Okay, from here, okay, to here, and their voice tackle is one right here. Okay, so how they do that? You can change whatever you want, position you want. Okay, you can change right here the go different location you want. I generate a path quickly. So here we have the map class. Right here the movement arrow, that's the mapping for the result you already see, and the movement direction movement up, down, right, left. Okay, so the template function for printing the board, the map. Okay, and searching function right here we create two one array, vector array, and expandable array. You can see that this array for mapping the arrow into the output. Okay, and we define the first location right here. Okay, and we create the two-dimension right upper list right here, and we push back all that value. G is the cost value is all equal 1. It means every time we move from another node, they add 1. Okay. For example, right here from here group start to here is 1. For here is 2, 3, 4, 5. Is increment 1. And how now we continue how they find the next node, expand the node. They will get the smaller cost of the next node and they push back into the open list. Okay, and right here we create a cow. Every time they get the new node, they will put increment into expand neighbor array. Okay, and if they find the goal, when they expand the node, they find the next node equal the goal location. Okay, they return the value. Okay, and right here we expand the node. We thus increment the movement direction. Okay, the value increment to check it, and if the cells valid or not, we check right here, and then they increase the cost path, and they push a new node into the open list. Okay, and right here we just create the arrow map. You already see that. That's for the mapping the arrow into the output. Okay, that's it. And in the main function, we just call the class right here, map planner, and print the map, and call search function, and we see the result right here. Okay, you can see the results. The expansion node right here. You can they use breadth searching, so they allow the iteration to find the node. Okay, right here you see they took about 111 iteration to find the goal. But anyway, the find the path. Okay, to get the goal. Good. Okay. So what happened right now in the graph search, and breadth search is the one of the graph search algorithm. In the graph search, you already know we have the uninformed and informed search. Uninformed include the breadth first search, depth first search, and uniform cost search. And it means uniform search, uninformed search algorithms are not provide any information about the goal, so they had to searching all the nodes. Okay, but informed search right here, for example, the Astar, they are provided with the information related to the location of the goal. So these algorithms are able to evaluate some nodes to be more promising more than others. This makes their search more efficient. Okay, so right now how to change to A-star search? It means how to improve the search, the breakfast right here. I call the heuristic function value right here. Okay, I assume that we already know the heuristic function. In heuristic means you calculate from the node to the goal, how far, the distance. But I assume we already know that. In the previous example, we already know, we calculate that. We use a really easy formula map and do it, okay? And we create the F value. F value really here the total value of the cost, pack cost, and the heuristic value. And right now, the open list, they had to include up the app value, right? It puts back all into the open list. And then they got the smaller value they put to the next node. Get the next node right here, because we had the 3, 1, 2, 4 value for item into the node. Each node they have the position as y, cost value, pass code right here, and the app value too. So right here, you know the location we put right here, the app. The first one is 0. Next one is the G value, gain value. Okay, and continue right here 2, 3. Okay, easy to understand. And right here we have to print out the value to see the last node that come. And when you get expand the neighbor nodes, we have the new app value. It means we calculate the totally from gain value and the new heuristic value for, and it puts back all into open list. Okay. Okay, that's it. Let's see how they improve the breakfast shows. Right now, you see, they also have the path from the star position to the go position, and you see right now, it's less iteration. Okay, that's 87 to get the go. And for example, right now I train to 0, 0 from here to here. Let's see how they find the path planning. Oh, we got it. Okay, from star right here, you go down, 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 and you see the arrow. They show the path planning right here. They go to the go. That's only 35 iteration to get the go. Right now, they don't need to calculate all the node because that's the informed searching algorithms. You already know the game, the heuristic value, the distance from the next node to the goal. So you just move forward together. You can calculate and you get the direction to move to the goal. So it's really cool, right? And you can play with it in the some another example. The map is really big. It's not like this. It may be the 300 by 100 is a large value, so then so help you to create the map quickly. Okay, in that example I show you how they create the path on the map, real map. Okay, so I search in this algorithm really useful for us. I hope you understand the basics, the how it works, and after that you really easy understand for a big problem, a big application when people mention about the Astar search algorithm. I know in the classes pipelining, they talking about the discrete planning. Discrete planning, they include up the roadmap, cell decomposition, and potential field. But I just focus on the graph search right here, and I saw the A-star search really useful for us in many applications. Okay, I hope you understand how it works.